So in this video, we talk about computer level hierarchy. So we know that computer consists of many things besides chip, and before a computer can do anything worthwhile, it must also use software. So writing a complex program requires a divide and conquer approach where each program module solve a smaller problem, and complex computer system employ a similar technique through a series of virtual machine layer. So here the graphical representation of the computer level hierarchy. So we can see that each virtual machine layer is an abstraction of the level below it, and a machine at each level execute their all particular instruction call upon the machine at lower level to perform the tasks required. And the computer circuit ultimately carry out the work. That's the lowest layer. So let's look at the layer of the computers. We have the 7 layer from level 0 to level 6. So at level 6, that's the where user interact with the computer. That's the executable program. Level 5, that's a higher level language like C++, Java, Fortran, and so on. Level 4, that's assembly language, and where we can have OCaml assembly code. Level 3, that's system software, like operating system, library code, and so on. The level 2, that's a machine, including the instruction set architecture, where we will discuss some of the architecture later on. Level 1, that's the control, that's microcode and a hardwire, and the lowest layer, that's level 0, that's the digital logic. Basically, that's constructed by the circuit, gate, and so on. Okay, so you can see that's multiple layer in order to construct build a computer, and all the work going down to the lowest layer where the calculation or processing gonna be performed. So let's see the level 6 that we call the user level. So that we have the program execution and user interface level. Level with the we are most familiar with, and where the user can open a program. The user can play music, listen to a radio, can watch a video, and so on. So that's the software and user level. Level 5, that's a high level programming language. The level with the interact where when we write program in a language such as C, Pascal, Lisp, and Java, and so on. Okay, so OCaml a high level programming language. We can develop different program. That's the at level 5. Level 4, that's the assembly language level. So act upon assembly language produced from a level 5. So as well as the instruction program directly written in the assembly language, and that construct the level 4. So level 3, that's the system software level that control executing processes on the system, protect system resources, or allocate the resource to different program and different software. Assembly language instruction often pass through a level 3 without modification and go down to level 2. So level 2, that's we call a machine level. So this known as the instruction set architecture, ISA level. So we can study in detail some of the ISA later on. So basically, level 2 consists of instructions that are particular to the architecture of the machine, and the program written in a machine language need no compiler, interpreter, or assembler. And basically, this level you for the higher level program language, they need to perform the assembly and also transform into the machine level where the lower level can understand the instruction. The level 1 that we call control level. So a control unit decode and execute the instruction and move the data through the system. Control unit can be a micro program or a hardwire. A microprogram basically is a program written in a low level programming language, and that is implemented by the hardware, where we construct the circuit to perform that. On the other hand, the hardware control unit consists of a hardware that directly execute the machine instruction. Okay, so we can see that microprogram is more flexible. On the other hand, um, the hardwire control unit is uh, that's not just flexible, where we want to change. We need to modify the hardware part. And the lowest level, that's the level 0. We call that the digital logic level. So this level is where we find the digital circuit, for example, the chip of the computer. So digital circuit consists of gate and wire and all type a hardware component where we construct and put them together to implement the mathematical logic of all other level. So we can see how the gate and how the digital component are put together to perform all type processing later on.